All right, everybody, welcome. This is the Houston.net users group. Too soon. Go back. Houston.net users group meeting for July. And since we're all remote, this is the greater Houston.net users group with our friends at the North Houston.net users group. Welcome, everybody. This is meeting number 210 for at least GHADNUG. And we're going to be talking about breaking the monolith byte by byte with Mukesh, Dhannawat, and Murali Venugopalan. Sorry, Venugopalan. Got it. Let's go next slide. Meeting agenda. We're going to talk about the meeting agenda first and foremost. And then we're going to have some announcements and some information. We have one illustrious prize to give away, a JetBrains license. That's going to be given away to those present to win. And then we'll have the main event. We're not going to do a lightning talk today just to give Mukesh and Murali more time to talk about and take questions. Let's talk about the microservices, and I feel like it's going to be a lot more technical discussion we do, so looking forward to that. Housekeeping, wireless, you're already connected to it. Congratulations. Your password is hopefully not admin. Restrooms are somewhere, and there's free snacks in the break room. Please help yourselves to any free snacks that you find. Things coming up. There is July 30th, the .NET conference focused on microservices, which came up in my newsfeed after I talked to Mukesh and Murali. So focus.netconf.net. And it's going to be all online. It's free, and they'll have a lot of talks about microservices related to .NET. So July 30th, you can go to the website to reserve your space, and you get reminded, and you can go in. Most likely, they'll have the sessions available by recording afterwards, so it'll be easy to continue. Also, Houston Tech Fest, September 12th, 2020. I think I saw Michael Steinberg on. Michael, you want to unmute and talk about it a little bit?
Is it working?
It is working.
As long as you can hear me. I wasn't sure. We're going to do it virtually. We just decided just like this week. So it's in process. You can still, if you want to make a presentation, you can still make a presentation up until August 15th. And between now and then, I'm going to try to put together the whole virtual infrastructure. We're hoping to have 4 or 5 tracks going at one time, and we'll see what happens.
And are the speakers are closed to call for speakers, or is it still open?
We reopened the speakers because we're going to do it virtually.
Okay.
So you got till August 15th.
All right, August 15th. You heard it from the source. Cool. And any idea of, I guess, are you going to use WebEx to do it? Because it's not that great.
Looks like we're going to use Microsoft Teams.
Okay.
And I've never used Teams, so I've got a little bit of a learning curve. But you know, hopefully I'll get some friends to get on me, and we'll test it, and everything will be pretty well figured out within the next month.
Nice. All right. Thanks, Michael. Appreciate you joining, letting us know about that. Any potential sponsors, please email sponsors@HoustonTechFest.com. And then, like Michael said, call for speakers is open till August 15. So I think that with the Facebook page and the LinkedIn page have the link to the speaker forum if you want to go in and submit.
Yep.
All right. So we just, so Houston.net users group recently joined the .NET Foundation group of meetups. What does this mean? This means that if you go to .NET Foundation and meetup, you'll see our events in the list with a bunch of other ones. And it also means that they'll pay for our meetup account. Yay! So it's been exciting. We're trying to see if they have other cool benefits that come with it. And they did say that they may send us some swag to raffle off as well. So not this month, but when it happens, we'll be sure to let you all know, and we'll raffle things away as such. Other news, as always, you can find Houston.net users group on Facebook, LinkedIn, and Meetup. YouTube, if you look for us, we'll have the presentations and also the one for this meeting, and subsequent online meetings will be posted in YouTube as well. And I'll have the link in the meetup comments after the meeting's over. So usually it takes about a day just to dump the conference video and load it in. No magic required there. NorthHouston.users group at northhouston.usersgroup.org. Twitter, GitHub, Facebook, also available, accessible. NorthHouston.users group has a sponsor, iSphere. iSphere, let's click on some links and see. Houston-based IT consulting and staffing firm, proven track record of both private and public sectors. iSphere offers extensive knowledge, demonstrated expertise from IT consulting on strategy, collaboration, information management to IT staffing to get IT done right. They may have had some jobs. They had some jobs posted. I put it on the slide actually. So these are the jobs posted for iSphere. Few options out there. Other companies that are also hiring. Improving had a few job postings. Not sure if those are active or really just listed. All over the place, different things. Catapult Systems had some as well. Headspring has a few. Available in Udesic. I think there was a link to it, and at least the Houston one didn't have anything, but there may be some more in other places as remote, because I think everyone's really learning that remote is possible and is going to be a way to do business. And here we are. So there is, if anyone else is, there's some postings that were also on our LinkedIn pages. People have been posting a few opportunities that are available. And if there's something you're looking for, you can reach out through the Houston .NET Users Group LinkedIn and see if there's other connections to be made. Or you can reach out to me as well, and we can try to hook up with other people. All right. Prize drawing. So looking at who is currently in the list. We have 22 people, including me, and I'm not counting. So we're going to pick a number. So 1, 2. So Tony, if you could pop up the a random number generator, and I'll give you a number. 1, 2, 3, 4, 5, 6, 8, 9, 10, 6. What did I do? I'm counting real quick. 1, 2. 21. So between 1 and 21, I need a random number. I had you on mute, Tony. Maybe that's what's going on. Otherwise, if you're not there, oh, you got a random number between 1 and 21.
13.
1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. JX is a lucky winner. Give me, and I'll send you the JetBrains SMS. All right, and I'll follow up with him afterward, him or her, JX. Congratulations. All right. With that, tonight's talk is Breaking the Monolith by Byte by Mukesh, Dhannawat, and Murali Venugopalan. And I'll pass on the presenter powers to Mukesh. Change role to presenter. Yes. And I will make sure you're unmuted, and Murali is also unmuted. All right. Mukesh, you are on the floor. You have presenter rights.
Okay, can you hear me well, Gaurav?
Yes.
Okay, great. Let me make sure I can share. Okay, I can. Hello, everybody. How is everybody doing today?
Fabulous.
Fabulous, awesome.
I'm speaking for myself, but yeah.
You're speaking for everybody. Can you see my screen, Gaurav?
Yes, your screen is visible.
Awesome, great. So we're going to walk through this presentation, Breaking the Monolith, how to accelerate deployments and development of the teams, the byte by byte, one piece at a time. Before we get in our topic, just a quick introduction about us. I have my colleague here, Murali Venugopalan, that will be joining me. of course, I had a pleasure to work with Murali for about 8 years now. Worked for the same company. We had a great run with the company. We grew about 5 to 6 times from initially joining the company. The revenues grow as well, 5 to 6 times. So we joined a company which was in revenue cycle management, a regional player, moving from 300 to 400 people to about a couple of thousand people by the end of 8-year run. And so, of course, Murali and we worked together at that place. Murali, of course, had a master's in computer science from University UTD, University of Texas at Dallas. Has about a decade experience with web development, web APIs, relational databases. He's working as a lead software developer right now with experience in microservice architecture, containerization, Dockers, and automated deployments, of course. On personal front, Murali is a father for 1-year-old, full-time father, right? And also he plays soccer and cricket. And that's about Murali. That's me, Murali.
Sure. Yeah, thanks, Mukesh. So yeah, like Mukesh said, I had the chance to work with Mukesh for about 8 years, and I knew him all the while. So Mukesh, I would say, is the person who recruited me out of college. So probably someone who put faith in like a novice developer coming out of college, just not knowing anything. So he's one of my mentors. He's I would say he's very technically inclined, a great leader. That's the way I see him, a very great leader. He's managed a team of about, I would say, at one point 20 plus developers, and that is a big thing. 20 plus developers, making sure a big product that's the flagship product of the company, getting all the business in, is working smooth. So that's Mukesh, and he's very technically like always on the cutting edge. Like I think he attends a lot more user groups than I do. So he's like he knows a lot of stuff, and that's like a catalyst for change, and always brings out good things. So that's what I've seen in him, like in the time we work together. So yeah, that's Mukesh.
Thanks, Murali. So we're going to get in our talk. Of course, microservices is the trend. I was surprised to see Gaurav present. That there is going to be a full day talk on microservices. So I think we'll not do any justice, but we can be an introduction, I think, precursor to that talk on July 30th, which will be great to hear. Now, before we get in our topic, it will be good to know a little bit about our audience as to, what, who are we talking about, or who are we talking to? To just kind of, if you can type in, I think everybody can message in the chat. If you can just type in your level of expertise with or familiarity with microservices, that will help us a little bit. We have, from anywhere, never heard of microservices to I am an expert. So I'm getting some responses here. Let's see. I'm getting a lot of 3s. Okay. It's a lot of 2, 3s. There is 1. That is good to know. So we'll be talking a lot to the 1. 2s and 3s. Nobody claims to be an expert here. That's good to know. Then, okay. Okay, so we have average about 2, maybe 2 to 3, 2.5 or something like that. So most people have either heard about them or used them infrequently, right? And that's where we kind of starting to use them more frequently now. If you really look at the trend on Google, this is from Google Trends. Just picked out it yesterday. This is kind of the trend for microservices on the Google. You will see that increasing interest in microservices over time. Of course, the whole topic is probably less than a decade old. It kind of originates from, in one way, service-oriented architecture follows some of the same characteristics at service-oriented architecture. Of course, there are some definite differences in the architecture style of microservices. We'll talk about that in a few minutes. But you will see the continuous rise. Of course, you will see the drop here. I think that drop is nothing other than the COVID situation. Because of that, probably there is a drop, some drop in the interest there. But that's your trends. So how do I pictorially represent, the two, right? So I was thinking about this. What is the way to represent it? And if you, search on Google, you'll see Lego blocks and this and that, and different ways to present what is a monolith versus what is a microservices. And then I was, thinking about this other movie that I've seen. I don't know whether anybody remembers Finding Nemo, and this is a great example of what is a monolith versus a microservice. There is a scene in Finding Nemo where the dad and Dorothy, they're looking for Nemo, and there's a group of fishes which come and try to kind of have fun with them. So they make different shapes. So these two kind of represent in one way. You will see that on the left, it's kind of organically grown, very kind of rigid and tightly coupled, right? You can't take different pieces out from one swordfish, right? But if you have a swordfish which is made up of hundreds of different swordfish, it's very complex. At the same time, it is, very flexible, right? And that's one of the main reasons why the architecture of microservices has been so popular, right? Because of the flexibility that it offers in terms of doing the software development in small components, right? So you can take that, you can convert it into any shape that you want. The components, you can rearrange them, right? You can rearrange them again. So basically what it stands for is basically you have independently replaceable and upgradable components. In each component is a service in itself, right? So they have very defined boundaries. So that's really the main focus on microservices, that it's made up, each microservice is independently replaceable as well as it's upgradable independently. So if you think about it in a physical form, you have your components in a complex device that you can, if you talk about your laptop, it is made up of many components which you can, replace or upgrade independent of each other, right? So you can think about a software like that, and that's kind of the microservice architecture we're talking about, right? Now, if you look at it diagrammatically, that's your typical monolith architecture, your n-tier application, one big database, you have the data layer, the business logic layer, and the UI layer sitting on the top of each other. No matter what business capability you are talking about, each of those layers have all of the capability for all of the business, right? So that's very typical. We probably all have worked on that, and that's where we started when we started the journey at the current company. That we're going to talk about a case study, in a minute here. And you talk about microservice architecture. That's your typical microservices kind of architecture where you have smaller APIs, which are each typically have its own, decentralized database. They are, cross-referencing each other, talking to each other, either synchronously or asynchronously through, queuing services, right? So that's your microservices architecture typically presentation. If you look at, there is a good example on GitHub. If we really want to play up with some code, there is a good reference application. There's a link here. I'll probably send out this presentation afterwards. But you can, of course, download the code, play with it yourself. These diagrams come from the GitHub page as well. So they have an example architecture here for like a shopping website. where if you look at the front end, you have multiple cross-platform kind of applications. They're using Xamarin on the front end, so it can be used on a mobile app as well as a web app. And then you see that on the right-hand side, you have a bunch of microservices that are broken down, each having their own database on the back end, right? Depending upon, and if you really look at this is where you will notice that each microservice is kind of split out by its business capabilities more than anything, right? So there is a catalog microservice where there's a maybe a division which takes care of the catalog. There may be a division which just takes care of the ordering system, maybe a division which takes care of the marketing. So you can independently work on those services independent on each other. You can have teams of people that are just working on the marketing microservice, ordering microservice, and they can independently work off each other without affecting each other, deploy their code independently. So I thought this is a great example to kind of see how a real world microservice may play out in an ideal case scenario. So that's an example for us. Now, when to consider microservice, when not to consider it. We talk about some of that pros and cons here. Because it's such a buzzword that a lot of people by default only think, there are people who can only think that, okay, microservices is the only way to go. So, is it all fun and rosy using microservices? Of course, the first and the biggest advantage of a microservice, it definitely provides a better modularity, right? Means, like we talked about, you're replicating your business capabilities, representing that. Can you do modular code in a monolith? Yeah, you can, but it is just difficult to have that kind of a discipline to control your modularity in a monolith. In microservices, it comes by default. Now, can you? So you talk about a monolith, and a lot of times you talk about this big ball of mud, right? And that's a concept. Now, if you don't follow good practices, you can end up being a big ball of mud, even in a microservice kind of architecture, right? If you don't have well-defined boundaries, so it is more inclined where it can provide you better modularity, and so that's one of the big advantage of microservices. With that, it comes with a cost, right? So the cost that it comes with is, they are distributed, right? They by default, if you're talking about more than one service, they all distributed, and then you need to work with distributed system. That means they need to communicate with each other. When they need to communicate with each other, there is remote kind of calls, right? Instead of in-process calls for a monolith. So you all, looking at performance hit, right? Because if you're talking to, you have 5 microservices talking to 5 before you get all the work done, that will definitely increase the amount of, calls that you need to make in between different components. Now, of course, you can reduce or increase that performance and reduce that overhead by doing asynchronous kind of calls, right? But then with asynchronity, it increases your complexity again. So that's one of main kind of thinking points you need to think about when you're distributing your systems and splitting your code into multiple microservices as to how they are going to talk to each other. Right. The second thing is, they are autonomous. That means they have their own decentralized databases. If each one of them have their own decentralized databases, it leads to eventual consistency problem, right? I think I notice this sometimes on LinkedIn. When I'm on LinkedIn and I'm sending a message, I do send a message, but it does not show up immediately in my message window, right? I don't know whether anybody noticed that, right? And you will see that with different websites that your update and your get are not consistent all the time. It takes a few minutes to eventually get it consistent. So that's the problem with the eventual consistency, where you're writing to your separate databases, each microservices, and then the databases need to sync up with each other. So of course, that use of course, if you look at the eventual consistency problem, there's the cap theorem also, where the business will always want to have more availability, and they can deal with less consistency or eventual consistency. But you need to have either one of them, right? So that's another challenge with typically working with microservices. But the advantage is you're able to independently deploy, right? That's a big advantage, right? Is able to have continuous delivery, even to the point where you can deploy multiple times a day, compared to a monolith. That's a big one, because in a monolith, you don't know if you change one piece of code somewhere, what else is it break, right? So typically, when we're working in a monolith, we had releases planned out every quarter. Our goal was to release pretty much when we are ready, right? Not how to wait till a quarter to release changes. And that's typically, if you look at the whole DevOps culture, independent deployments, if you want to accomplish that, you have to, in some way, have some kind of automated deployments. Can you have automated deployments with a monolith? Yeah, you can, when the monolith is small enough, right? So that's a big advantage of microservices. It's an advantage. At the same time, it's almost like a prerequisite, right? You cannot have a lot of microservices and not have automated deployments, because you can't deploy microservices manually. So we'll talk a little bit about that. I think there was some deployment slides, but so the other thing is when you have the complexity, the operational complexity increases, so automation is a need. Monitoring is another need when you talk about microservices. So that's pretty much a requirement as well, that you need to have identified monitoring and dashboards to monitor all your services. The advantage is it enables technology diversity, right? So each microservice can pretty much use its own language or library, right? So if you're working on a service which is great for Python, you can use Python for one microservice, versus the other one can be in .NET Core. Again, the databases can be the same non-relational databases as well as the relational databases, based on the need for that particular microservice. So that is one big advantage, that you are not locked into a particular stack, right? You can use different stacks based on the skill level of your team. Again, you need to probably cap it at some point, some level. So everybody's not using kind of different technologies, but you have the advantage here. And on a longer run, the technical depth of this, because any code you write today is already old for tomorrow, right? So if you have to replace a monolith, it's a much bigger effort than tomorrow when we'll have to replace the microservices. It will be easier effort, because each microservice will be smaller amount of code, which can be independently replaced, right? So that's a big advantage of microservice architecture. So in the end, of course, it sounds awesome, but there's no free lunch, right? So you'll have to put in that extra work to make microservices work for you and your case study. So what do we all move to microservices? The typical answer is the typical consulting answer, right? It depends. So it really depends on your need. But I think I really found this graph very useful when you have to determine whether you want to move to microservice architecture or not. Right? It is, and I put the link out there. It is by Martin Floor. I liked his blog postings a lot on microservices. So you want to, he probably can read on it. But this graph is from his website. It talks about how productivity versus complexity. So typically, when you are starting a new project, a lot of people want to start with microservice architecture, but it's in one way kind of contradictory, right? You want to start with a monolith which is well modularized to start with, and as your business need or complexity grows, you can split that more and more into microservice architecture, right? So if your base complexity is less, you are better off using a monolith, right? And how do we define complexity, right? It's different definition for everybody, right? You can define it by team size, right? Or you can define it by number of lines of code. Typically, if you have a team of less than 10 people working on the same code, you're better off having some kind of a modularized monolith than you're working with a team of 20, 30, 40 people. If you're working with a bigger team size, you will have to eventually go to a microservice architecture, right? So it kind of gives you a good visual here as to how, as your base complexity increases, the productivity with monolith decreases, right? And that's what we experienced in our case study, right? Our monolith was more than 15 years old, so it became more and more difficult for us to add new features. But with microservices, the productivity is less initially, but as the complexity increases, your productivity almost remains the same, right? So that kind of is a good visual way to decide if you're deciding between the two, which architecture do you want to start with. Typically, if you're starting a new project and if you're not catering to hundreds of thousands of people, if your customer base is going to be a few hundred people, you're probably going to be better off starting with a monolith. Is kind of the suggestion here. Any questions or comments so far? If not, we'll go in the case study.
Yeah, I have seen one other big advantage of using microservices especially with something like messaging bus is that each microservice is independent of each other. So let's say if let's say one goes down, which the other one is dependent on the data, they still work efficiently because their data is there. And the other thing, but disadvantage is that you have some duplication of data as well.
Right. Yeah, absolutely. The resilient is more in terms of microservices, right? One part can be down, especially the message can be waiting in the message queue, and it can retry after the service comes back up. So absolutely, it is more resilient. Yeah.
The big thing I've always heard is that you should never start with microservices because until you see that you need it. Exactly your graph here. You're always going to start simple to serve your customer base. And then at some point, you have to justify the complexity of going into a microservice. Anyone that tells you to start that way is trying to sell you something, I think.
Yeah, unless you know that you're building Amazon or something, right? It's just what kind of customer base you're catering to.
But even Amazon didn't set out to build an Amazon.
No. They did not, yeah.
So,
they started with monolith.
Exactly.
Absolutely. Okay, great, guys. So in our case, we had a monolith, right? And it was a Windows Form application on the front end using VB.NET, a WCF service as a middle layer, some business logic here, and a database which had a lot of business logic as well in store, procedure, functions, and views. So that was our application that we built. It's a FAXio application which drove our revenues. About $200 million of revenues through this application. This application launched 15 years back, and so we migrated from a AS400 application to this .NET. So it was a big upgrade, right? You're seeing upgrading from the black screen to some kind of a UI-based Windows Form application. So then we continuously upgraded as our business grew. As we became more and more of a national player, there were more features which were required to be built in the application, and so our code base grew and number of team members, right? From a couple of developers, like Murali said, we had 20-25 people contributing to the code base at one point. So with that, that kind of, as you saw in the graph there, we saw that decrease in productivity, because of increase in, of course, the team size as well as increase in the business need. We also needed to refresh our technology, right? We were still stuck on the Windows Form application. We wanted to go to a progressive web app, which can be used on multi-platform kind of, which can be used on a tablet and it can be used on a mobile app. So that was a big thing for us to be able to support our customer base. And then the next thing was really, supporting this agile DevOps culture and be more scalable, right? If we are at 12, 20 people, if we need to add another 10 developers, can we really scale the team well enough where those people can be contributing to the team, right? So that's another thing we wanted to solve. So it was almost like this, right? You're sitting on a table and you have all the table laid out with the plates and you want to change the tablecloth under the table. That's the analogy I will say, right? Because this application is not like the monolith application is not being used. It's been used, and that's the case in most cases, right? Can you rewrite the whole monolith, as a one big bang, or do you kind of set up another table, or what do you do in this situation, or do you pick one plate at a time and take the rug or the cloth under the plate, the tablecloth, so we went with the second one, right? We picked one plate and kind of replace the tablecloth one plate at a time, instead of doing the one big bag theory, which is pretty much, that's a common sense kind of approach in today's world, especially when you're looking at delivering incremental value to your customer. So our approach basically was to choose a project where we can deliver business value, right? So that's a big thing, right? You can't just tell business that, hey, we are working on this technology upgrade project, so we're not going to deliver any new business value, right? So the new business value for us was, we're going to provide you a better UI experience, where you will be able to use the application on multi-platform, right? Instead of having to stuck with the WinForms application, it will be a progressive web app which can be used on any platform that you want, right? So we wanted to roll out tablets to our users who were mostly front-end facing the patient, and they want to use that application to do screening on the front end, right? So we identified what business value can we add while we are doing the technology refresh at the same time, right? The second thing is, this is a common example again of a strangler pattern, right? Instead of, like we talked about, instead of doing a big bang theory, you want to do this. This comes from a tree called strangler fig tree, where the tree goes from the branches down, and when it's fully done, it kind of has eaten away the tree in between, but it looks like the tree in one way. So that's kind of the approach most people take, and that's the approach we took when we wanted to redo our monolith in different microservices, right? So we split one thing at a time, and then the last thing is the upskill of the team members, right? So we got some increased capacity through consulting help to complement our current resources, to upskill as well as increase our velocity to be able to deliver the product to the market quicker. So that's pretty much was our approach. Now I'm going to hand it to Murali. Murali, you want me to continue sharing? I can't hear you, Murali. You're on mute.
Yeah. Okay. Can you guys hear me now?
Yeah.
Yes. Okay. So yeah, you can continue. I'll just talk. Yeah, like Mukesh was alluding before, we took that approach, and now the next question is, what is the technology stack going to be? How are we going to split it up? So, starting with the front end was supposed to be or is a Aurelia-based, JavaScript-based UI. Now, what is Aurelia? Aurelia is a JavaScript framework which is backed by Decoupled, pretty common out there now. Compared to other big players in the market like Angular, React, and others, it's probably not that much. Like people don't know much about it, but it is I would say it is pretty good. So personally, having used it and worked with it, I would say it is a big competition to Aurelia, Angular, and any of the other ones. Just depends on what the skills your team has and what's the best way for you to get your product out quick. So now when we had consulting help, they had really good experience with Aurelia. So that was one of the big factors in why we chose it. So that takes care of the front end. Now breaking the monolith into microservices, it's going to be again a lot. So we started with the basic big pieces. We had a couple of APIs we marked out, which we called the accounts and the workflows API. Now this was going to be the biggest and the most intense work. Like accounts and workflows together could probably run about 80% of the application.
Hey, Murali, I just want to listen. Your audio is coming in and out.
Okay, better now? I'm going closer to the computer. Is it better? Okay. All right, so I'll keep going. With the so like I was saying, accounts API and workflows API was supposed to take up the bulk of the work. They were going to be the ones running the show, and they were two separate, I would say two separate pieces of the application forming the core. Now, all the other services are around it. If you think about it from a monolith, these are all going to be built into the same application. Now, if we start breaking this out into smaller services, we could at any point switch out one for the other. Like let's say we change a vendor, and we could easily switch out that integration without having to completely take down the entire application, which would be the case with a monolith. So in our case, it was I've listed out a few APIs here. These were the main ones, and they were all deployed in Docker containers. Now I'll touch on Docker containers and probably go through in the demo with Docker. Dockers is basically using a containerization technology to host your applications without actually separating them out. These are more like OS virtualization hosting, where they all reside probably on the same computer, but they're still isolated in every way from each other. So that's the simplest way to put Dockers in. And the last part was our big database. Now, we were tied in through a big monolith database. Now, Mukesh will touch on this on our slides, but this was one of the things which we had to keep. We just could not figure out a way to change it. And there was just too much pressure from the business to get things out the door quick. So now that's always going to be a challenge. Now, is it the right way to do it? Yes and no, right? Depends on your situation. Can you do it this way? Yes, you can. Can you not do it this way? Yes, you can. So it just depends on what works best for you.
So I have a question. So since you were using the old database, but you were separating out your microservices here, how did you deal with the dependencies in the database itself? So let's say one table is dependent on the other and you're inserting into it, but it needs that other key or something like that. How did you deal with those problems?
So, so if you think about it, the way we deployed it, we would say the first iteration didn't cause those issues because they were completely isolated. Like Mukesh said, the approach was to first pick a project which was brand new, which didn't exist in the monolith, and then just bring it up. So that initially we never had those issues. Now going forward, we started taking away some things from the monolith. Say, like as soon as we had some built out in the microservices, we would deploy that and have our user base switch and start using the new application. So it was a small problem for the users having to switch between the monolith and our new application, but I think they found they found the new application good enough to where they were a little bit more flexible in wanting to use it. And then that got rid of those problems. So anything which was, and again, we picked out things which were completely isolated for microservices, that being the whole theme of the grand things, the grand scheme of things, right? Does that answer your question?
Yeah.
Okay. Going forward, so now that we have everything broken out, there's going to be 15 services. There's going to be UIs. Even in very complex architecture, there's going to be 15 components for the UI, just making up the UI. So what are we talking about? Talking about automated deployments, because if the developers just start building out all these smaller things like microservices for every small thing, the deployment engineer is going to have a nightmare. Like he's going to have to deploy 65 applications in one night to make sure the application is working right.
Murali, your audio's cutting in and out again. Sorry.
Okay. Yeah. So, so with microservices and deployments, going into the DevOps culture and using that is the best way to go. So automated deployments make deployments convenient, makes it easier, and like it's just so much better. So now what I have here is some screenshots for how you get started with automated deployments. What I have is a screenshot from Azure Devops, and this is what is the CI part of CI/CD. Now, CI is continuous integration. This is where you build your code at a certain interval. Now, if you see the very first slide or the very first screenshot, which is on the left, you can see multiple steps, and this would replicate the steps that would generally happen when you try to build a .NET project. You would technically first restore the project, build it, run the test project, and then go ahead and publish it. Very basic steps. Now, what you can do with something like a CI pipeline is you can list all these out, and you can say these all happen in sequence, and you can also add additional steps if you want. Like if you see the first two steps on the screenshot, they generally don't happen in a .NET project, but this was necessary for us. Like we had to move certain files around. We had to run a cleanup script in the beginning to make sure everything's clean when we start the build. So this is the flexibility you get. Now, the second screenshot, which is the top right one, is what is the trigger. And that's there on the screen right now. So that's the trigger I was talking about. Now, the question is when and how do you build? A very simple and logical solution for that is I build every time there's a commit. As simple as that. Now, can you pick and choose the branches you want to build on? Yes. So that's what we were doing in our company is we build every time there's a check into the master. So people work off of their own private feature branches or their own private branches, check into the feature branch, and then there's code reviews and pull requests coming into the master branch. Now, as soon as a pull request is complete, which means a feature is complete, there's going to be an automatic build that's going to be triggered, and that's going to build the project. So now, what that means is as soon as someone checks in code, within the next 5 minutes, I'm going to have a deployable, like a build ready to go deploy to any one of my environments that I have. And that just accelerates the deployment. Nobody has to go make sure all the dependencies are ready. You don't have to go check whether a certain script was done or like a migration script is ready or not. All that part is going to be taken care of in the continuous deployment process. So here, and then one of the other things I want to touch on is also versioning. Well, it's very common, like with agile and moving so fast, you could have 15 builds in one day. And that means we got to version our numbers correct, or like we got to get version numbers correct. So with CI, you can actually automate the process of versioning too, to where you can define how you want your version numbers. And then every time a new build is created, a version number is slapped on it. And you can basically refer to everything with version numbers. So that's this is a good introduction, I would say, to CI. I would stop here at this point for any questions.
Yeah. So did you have one repository for the whole project or one repository per microservice?
It was one repository per microservice.
Oh,
And then as you build and check and code, it will be all together.
oh, okay. That makes all right. So, thanks.
Okay, so sorry, was there another question?
Yeah, I was going to ask, do you have like a running sample or example of the configurations that you use for this as part of the something shareable of what configurations you use to drive this, or is it all just?
I don't. Yeah, no.
Okay.
I just have some screenshots.
Okay.
Yep. Okay, so now that the build is ready, the next one is actual deployment. With deployments, now deployments come in multiple stages, right? Like first, the developer completes their work, then it's got to be QA tested, then it's got to go to the users who will then do UAT testing, and then the final show, which is going to production. So that defines all those different environments that you have. Now, the ideal use case is to set up different environments, which are basically replicas of each other. And now, and then you have to deploy to each of the environments in a progressive manner. But that also means someone has to go sit and move files around or do whatever it takes to get the application out. Now, even that part is the second part of CI/CD, which is continuous deployment, and that can be automated too. So this is the screenshot that I have for the different environments we had set up over there. So we had 5 different environments. And if you see the way they are laid out, that is the sequence in which it happens. So dev and hotfix were essentially at the same time. So anytime there was a change in code and it's done, it would, and it gets checked in and a build is created, it would get deployed to both the environments. Now, there are filters set out to say if I build on a certain branch, it gets deployed to only a certain environment. And that has to go do with all your branching strategies. Git flow, a lot of people use Git flow, and there's all the other ones. We had our own branching strategy on how we wanted to do it. So based on that is how this one is built out. And you can customize it to however it fits best for your organization. So in this case, the continuous deployment trigger, which is the second screenshot here, is what I was talking about, where I said, anytime there's a build on a certain branch, I can have it start a deployment to one of the environments. So in this case, you can pick a branch and say, anytime a build happens on the hotfix branch, I want it to deploy on the hotfix. And then, so now deployments can happen. And that's why you have 2 conditions, which is pre and post deployment. So now when pre-deployment, you can define people that need to either approve it, or if it needs to happen after a certain other deployment that needs to happen. And this is where you can do like multiple deployments. Let's say only after it's been deployed to the dev environment and it's been there for a little bit is when we need to go deploy it to the test environment. Like it did not go directly to the test environment. And that all that can be defined in the pre-deployment conditions to say if one of the conditions fail, the deployment doesn't happen. And then there's also checks and gates here to say, okay, has a certain user approved it? Has someone looked at the code before and made sure this is all good for this build to go into a higher environment? So that's the automated deployment part. And this is as simple as going in and clicking a button is what the deployment is. And what happens on the click of a button is the next slide, which here again, just very similar to the build process, you can define what it takes to deploy your application. So now with microservices and Dockers, and I'll touch on a lot. I'll show how we deploy in Docker during the demo. But with Dockers, the basic idea is to create a Docker image. A Docker image is, I would say, like a blueprint of your application. It says how to go in and it builds it. It's like a compilation of your entire project. Once that image is ready, you need to go run that image inside a Docker container. And all those are the steps that are involved in my deployment. The one step that I have, which is visible on the right side, is the actual deployment process in Docker. I have an image ready, and I'm basically saying, start a new service, and these are all the properties for the service. Now, Docker, everything in Docker is a service. It can be the UI, it's still going to be referred to as a service. So those are the steps that are detailed in here. And I'll go over a basic Docker deployment. It's not going to be as detailed as it is in this screenshot, but I'll go over some Docker deployments during the demo. Any questions at this point? Okay, moving forward, Docker containers. So since we touched on Dockers, I just wanted to quickly talk about Dockers. What are Dockers? I gave a brief introduction. It's OS virtualization, keeping your applications isolated on the same machine, even though they're not physically isolated. They could also be physically isolated, but it just depends. So that's what Dockers are. Dockers, the whole concept is to keep them containerized inside a container where they're self-sufficient and they have their own resources running on, and that's it. So a quick visual representation of what Docker is compared to a virtual machine, because that's the closest that comes to Docker, and that's where a lot of monoliths live today, is virtual machines. Like if we need to separate out something, the very easy solution is go stand up a new virtual machine.
Quick thing, Murali, your audio is going in and out again.
Okay.
Is it the battery? Is it the battery on your headset, or is it?
No, I think it's just the mic not picking it up.
Okay. Because it's louder, more feeling, energy.
Right. Yeah. I guess. Yeah. So with virtual machines, quickly gonna recap or talk about a virtual machine. So with virtual machines, they sit on a server blade which runs an OS. So there's a host OS, something like a VMware, and then a virtual machine has its own guest OS. Then that can be anything that you want. It can be Mac, or not Mac, but it can be Windows or Linux or whatever you want. And basically you partition off resources which are connected to your host. So if your host has like 100 gigabytes of storage, you partition it out by the virtual machine. With the Docker environment, the Docker actually is sitting on the host OS, but it doesn't need a separate OS to run. Like each of the other applications, they are basically running off the same OS kernel, and they don't need their own OSS to run a separate container. So that's the big difference. Why Dockers? It's great, as in it's very easy to deploy to them, and they need very little to set up and get up and going, and compared to a virtual machine. And it's also, from an infrastructure point, it's also pretty cheap, as in spending money on licenses and virtual machines. It's too pricey compared to Dockers, where you just need one license and then you take and you run it off of that machine. How good how robust your infrastructure is in terms of how much memory and data you can put in on one virtual machine. You can run multiple Docker containers on the same machine, or you can split out your Docker containers in multiple machines and call a Docker swarm, is where they all run together with one master node and multiple worker nodes, and they split amongst themselves. The other good thing about Dockers is with a Docker swarm, like I was talking about, is you don't have to worry about where your application sits. The Docker swarm is going to take care of it. As in, I deploy it to the swarm, but then is it running on server 1 or server 2 or server 10? It doesn't matter. The Docker swarm is going to keep moving it around based on the load and the capacity of each single server. And if it sees one to be stressed, it's going to just pick it up and move it to another server without you even seeing that it went down for a millisecond or a microsecond that it goes down. Those are big advantages of Dockers. That's something I want to touch on. I'll hand it over to Mukesh.
Okay, great. Can you hear me now? Yeah. Okay, great. Okay, great. So I think the other good point about Dockers is, the reason we went with Dockers was also because we're still on-prem infrastructure at that time, and of course we had the intent to go on the cloud. So being hosted on Dockers, most of our microservices, it did not just matter, right? The Dockers can be hosted on virtual servers, which are hosted by us, or they can be hosted in a cloud, serverless kind of hosting. Docker's Azure offers a lot of serverless options. Of course, Murali was talking about Docker swarms. There's Kubernetes to do the same kind of orchestration of different Docker hosts that can be used, and that is very popular right now. So I think that was the main thing. Now with the project, I'm going to go through this quickly so Murali has enough time to go through the demo. But I think we had a decent success in terms of business value. We delivered the business value that helped increase the company's network. The company was looking at getting sold, so it helped them get sold because of the new value that was added because of the software that we created. Of course, we built a new UI that can run on tablets as well as PCs, so that was a big success as well. The technology value, we moved to automated deployments and of course modular code base. That was a big win for us to upskill our existing team to be able to understand and use the technology that is out there. And then the last one is we developed a pattern so we can break the monolith further, right? So the one fish escaped out of the pond, and then the others can follow. So that's the big success that that we kind of followed. Now again, like with any project, we had a lot of lessons learned. Some on the leadership level and some on the technical level, right? On the leadership level, we had, of course, inconsistent leadership that we went through. We went through. I would say it was a 1.5 to 2 years long project. In that 2 years, we had 3 different CIOs to go through the company. So each one of them had their own style of leadership and how they wanted to do it. Some wanted to outsource everything, some wanted to insource everything, and some wanted, So I think that's one big challenge that we faced during these 2 years, that our leadership were not consistent in what they wanted. The alignment was not there because of the change in the leadership, both on the business side as well as the IT side. Now, the other thing is, like a lot of big projects, we did not, one of the things with Agile is the product owner role, right? So the product owner role was not well defined in our situation, right? We did not have a dedicated product owner that kind of drove the requirements. So that, it did not help out with the alignment for us. There was, of course, we're doing demos, we're following Scrum, every 2 weeks, every 4 weeks, we'll do demos, we'll deploy to kind of UAT test environments. The product cannot be deployed to production till it's fully developed, right? But we will deploy the pieces of it in UAT, make sure we get a feedback loop from our users. The thing that we didn't notice that we were not getting the feedback from the right kind of users, right? So we will show the demos to, what we think the stakeholders who are not your frontline staff, which is going to use the application. So as we, came down the path, when we start to actually pilot this at a couple of hospitals, we realized that, the hospital depends, the connectivity at a hospital is very intermittent. We did build in some features to support offline mode kind of ability, but we almost had to redo a big piece of our coding to support mostly client-first kind of approach, where we were caching. At one point, we were caching almost everything in the web browser, right? And then it will sync it back to the server when it has a good connection, right? So we have to change our style of how we were communicating back to the server, and we could have done that earlier than later in the whole development cycle. We have to redo the UI 2 to 3 times because once we rolled it out, the users had a lot of feedback on UI. So those are some of the challenges. And then the transition to the in-house. And like I said, we had consulting help to start with. Eventually, the goal was to have the in-house team kind of scale to be able to keep moving at the similar velocity that we had with the consulting resources. And so the transition wasn't smooth enough, kind of ran out of budget, I think, on that. So we had to abruptly cut the outsourcing resources and kind of bring everything in-house. Technical challenges, the logging and monitoring observability. Unfortunately, it came as afterthought. The deployment came as a before thought. So we did the right thing with automated deployments, automated builds, all of that. We did not do a very good job with logging and monitoring when we started to build this application. So as we rolled this out, we started to understand that, of course, there are issues. And in a microservice kind of architecture, compared to monolith, it's difficult to find out where the issues are coming from unless you have good logging and monitoring systems. So I think it came as afterthought for us, where we had to scramble in the end to put in a lot of logging and monitoring. So I think that's a big takeaway. If you're building microservices, building logging and monitoring as a necessary step when you're building those services out. The second thing is, like Murali said, we're tied to a monolith. We did it deliberately, so we don't have to, we can deliver the value faster compared to trying to break the monolith databases into smaller pieces for each microservice. So I think that was a plus and minus. We could not see the same kind of performance gain you should see from a scalable microservices, because I think some of our performance bottlenecks were at the database level. I'll probably, if I had to redo it, I'll probably at least have some of the microservices have their own databases and data stores independent of the big monolithic databases. And the last thing was, we did not use any kind of queuing techniques between, talking about, when the communication is between microservices. Most of them were asynchronous calls, but they were direct calls. So if there were call failures between two services, there were no, reattempts and things like that, which caused more problems. So, we should establish some kind of queuing techniques for communication between different services. So those are things that we had for future roadmap afterwards. But some of these things should come as you're building your microservices, is what I thought was important. I'm going to take a pause here. We're going to go in the demo after this, but any questions or comments on any of the information we shared around the case study?
I got a quick question. So what would you say were the specific successes? Did the company see successes from going with microservices in its implementation, and what specific things did they get out of it?
Yeah, so in terms of technology, I think the one thing we saw definitely is that we were able to deploy much faster compared to a monolith, right? So, we adopted also a total DevOps kind of a culture where, we pretty much, you have your development team also doing pretty much supporting the application in production, which was also not the case with the monolith. So there were definitely a lot of gains that the business saw as well. Of course, we could have gone with a monolith for the whole new architecture as well, but I think going with a microservice kind of architecture gave us the ability to be able to independently scale, independently work on features of each other, and then ability to also scale the team size. So at one point we were planning to add a totally new set of features, and we could start working on that in its own microservice without affecting the other pieces of the puzzle.
How did you manage documentation? Because as your system gets bigger and bigger, you're like, no, you didn't have any of that.
We did have some wiki. We use Swagger for most of our API definition. I think Murali is going to show Swagger in a minute here. But really, if you do a good job, I think again, documentation came as afterthought, especially when we needed to transition out of the consulting to in-house resources. That's when we suddenly realized, oh, we don't have any technical documentation. So then we kind of ran into
So, so since you were converting the old application to the new one, how did you deal with that data corruption? Like, because you were using it so that you still maintain the latest data even in your microservices. How did you do that?
Yeah, so that's where we did not move away from the monolith database. We kept the database the same. So both monolith
okay.
and the microservices wrote to the same database in the backend.
Okay.
We did move away from business logic being in the database to the business, like the microservices layer. So we had a
Okay.
lot of business logic in store procedures and SQL jobs and other things. We deliberately made an effort to make our databases more dumb, and the business logic kind of move away from databases. So that's our attempt, so that then we can split out the databases into different pieces. So it kind of was a step-by-step approach. But yeah.
Oh, okay.
Okay. So I'm going to go hand it to Murali. I need to probably Gaurav, can you make him a presenter? He's going to share some code with us. Okay, Murali, it's you now.
It's done.
Okay, can you guys hear me? All right, so let me start sharing. Now, do you see my screen?
See PowerPoint.
Yeah, so I'm quickly going to talk about what's in the demo and then pull up which was covered and start going over the code. So with the demo, I tried to put together some very basic files. Now, these are not going to be anywhere close to an actual production ready microservice. But what I have is 3 separate web APIs. These are .NET Core 2.2 web APIs. The first one's a very common authenticate API. All it's going to do is let me log in to a hypothetical application. So, and in the background, it's going to talk to a MongoDB database for which stores like all my authorization and authorization level information. So separate database for this API. There's going to be another API, which I'm going to call the accounts API. It's going to return me a list of accounts. So nothing fancy. It has a MongoDB database too in the backend. It has a list of accounts, and then it's going to return me a list of accounts. Now each account's going to have an address, and in my scenario, I'm thinking using the address, I'm trying to ship them something, and this is where I have a third-party integration with some postal company like FedEx or UPS or something like that, and that's going to be a separate API. So in this case, if I, for some reason, decide to switch vendors, it's going to be a quick swap out of my microservice for a different vendor, and that would solve a problem of not having, it would reduce the downtime of my service. So this is the hypothetical scenario we are going to go through. And let me start showing some code. So yeah, here, this is a solution I have, Visual Studio Code. I have a solution with 3 APIs in here: account API, auth API, logistics API. All of these are the different APIs we spoke about, opening up. And Mukesh and Gaurav touched upon documentation. So with API documentation, I'm not sure how much people are aware about Swagger or how much people have used it. Swagger or Swashbuckle is one of the most common ones that people use. Now, what that does is generate automatic documentation based on your code. And I'm going to pull up one API really quick and just show the UI. Right, and this is what a Swagger or a Swashbuckle UI looks like. So this is the documentation for the authentication API. So you can put in some description about your API, and based on your controller and your methods in the controller, this is automatically going to generate. There's nothing special you have to do. You just slap it on, and I'll go through the code on how we do it. And this also lets you test your API. You can quickly submit requests from here and test out your different endpoints. So that's added plus, and your different schemas as to how each one is built out. Like what are your requests and responses and any other objects that you have in your code. So going into the Authenticate API, a regular .NET Core 2.2 API, like I said, this is going to have your regular startup class. And here is where, so using NuGet package, I added Swashbuckle to this. The package is installed, and once the package is installed, I just go in and inject it as a service or add it as a service. Now, this is the service right here where it says service add Swagger. It adds the Swagger documentation here, and this is where I define the title and everything. And that's pretty much all it takes to get Swagger enabled. And then right down here, I just say the application is going to use Swagger in configuration, and it's going to use the Swagger UI, which is going to be available on this URL. So it's going to be your same application URL followed by this relative path, and it's going to provide you the UI that I just brought up. So simple stuff on the documentation part. Now, the next thing that I want to touch on is application settings and how that can be used for something like a connection string or any application specific information. So in my app settings file, I added a new section called MongoDB. It's going to have my where my MongoDB lies, what's the database name, what's the collection name, and all of that. So this now to use this in a regular ASP.NET or something, you could just pull up the system classes, right? Like for configuration, system.configuration, and you can do the config directly. Now with microservices and with .NET Core, we can leverage dependency injection to get our configuration loaded into our service. And that is what is being done here is on startup, the configuration is injected into the constructor. And now I have a configuration class that I can use for reading any type of config. And this is where I'm doing that. It's here. This is where I'm configuring the service. But so the configuration is injected in. Now, when I'm actually going to be using it, I will be using it using this injected object. So with the way I have it worked out here in the application is I created the connection for the database in its own service. I called it the user service. And this is where this does. So here is where I get the DB connection. This is the IDB settings which is injected in here. And then once I get it, and now I can create a MongoDB client and then connect to the database. So my connection is always in here. Whenever I need to use it, I can use this service, which would automatically do the connection, get it ready, and I can have all my calls in here for the database. Very simple calls here. The get is just going to give me a list of users here, and then get by username is going to let me find a user in a collection. So this one, now, since this is registered as a class, what I do in registration is on the startup of my service, I go in and register my user service as a singleton. So what this is going to do is it's going to create one instance of my user service, which is reusable. That way I'm not leaving out open connections to the database and forget to close it. I don't have all those connection issues or like memory leak or connection leak issues in the future. So yeah, the service is being added as a singleton here and then being fetched here. Any questions at this point? All right, so a quick demo of what it looks like. I have all the services running, and the next part I'm going to go over deployment and Dockers. So that's where this will come in. But all of these services are now running on localhost, like the 3 APIs that I spoke about. And you can see it has, I'm using Postman as my UI to test my APIs, and you can see the services running. it tells me I'm unable to authenticate the user because the password is incorrect. I go in, update the password, and it's gonna authenticate me 200 OK and returns me a session. So this tells me my service is running. And at this point, I just want to show the Docker setup and really dive deeper into this. So this, there's multiple ways to view your Dockers. One of the easiest ways I've found is to use it from Visual Studio Code. There's an extension you can install for Dockers. And once you install that, it lets you connect to a Docker or shows you your local Docker. So right now, I have Docker running on my computer, and that's where all the containers are. So I'm able to directly see it from this view. And if you see here, these are all the APIs. Everything with the play right here is all the APIs that are running. And those are all the containers in my Dockers. And one of them is the account API. And this is the auth API and stuff like that. Even MongoDB itself is running as a container in the Docker host. So that's the architecture right now, and that is the API. So quickly going through the next API. This is the account API. I have the token put in here, and then when you send it, it's going to list me, like I said, just a JSON of a list of users or a list of accounts. Now, assuming I'm going to try to send something like a mail to one of these, I could go in here, request a label, each one here. So here with the body, I'm going to say this is my address. I'm going to copy an address. Right, and probably like £4. I don't want priority shipping. Assuming this is talking to one provider, it's going to return me what the cost is, what the tracking number is, and an estimated delivery date. And also I can go in and I can track this. Track it. It's going to return me a tracking history. It's going to say shipping info started from California and reached Spring. So pretty much tells you all the APIs are running, all the APIs are working. Now, going into Dockers and deployments. So we saw all the APIs were running, but how did I get to this point? From the solution, now you can use the terminal in Visual Studio Code, or you can use any PowerShell or Git Bash, any Bash client, anything that suits you best. So I'm in one of the APIs. I'm in the logistics API that handles the mail labels and stuff. With Dockers, the very first thing is I want to create the Docker image. Now, to create the Docker image, I need to build a project. And this is going back to when I was talking about continuous deployment and continuous integration. This is the CI part, the continuous integration part. So when I want to do something like that, I'll do something like Docker build. So right now I'm in the source directory for the logistics API. So I'm going to do a Docker build here, and I'm going to tag this image to something like test mail API. This is the name for my Docker image, and I'm going to do it from the source directory. I'm just going to do it from here and build everything. So this, if you see, it ran through steps. I ran through a few steps, and at the very end, it says it's done. Now, when I go to my Docker extension, I named it test mail API. I should have an image here which says test mail API, and there it is. So what this means is the CI part is complete. My code has been built, and I have something that is ready to deploy. So this is where I'm ready to deploy. This can sit in here, or I can deploy it to one environment, not deploy it to other environments, and leave it at this point. And then if we say this build is bad, we just discard this image, come back, create a new image, and start from there. So that's the good part. Like, you can come in here, get a deployable image, and you can also have multiple versions of the image. You don't have to have just one version, unlike a monolith where you have just one. So once this is ready, the next one is to actually deploy the service. Now to deploy the service, we would do what we call the Docker service create. But before I go there, I want to just show some code for the build. So here I just did a Docker build, but what actually happened is I have some code in here that defines how to build a project. With Docker builds, you generally always start with a Docker file. This is your blueprint on how to build your project. And with this project, what I'm saying is I'm copying everything, which is the CS project files, and then I'm running .NET Restore. Now, drawing parallels from the screenshot I had before, it had a step for .NET Restore, and this is what is being done here. I restore the project, and then I go in and copy everything else, and then build the project. So now I'm doing a .NET build, and then publish it, and then I'm gonna get this ready. And once this is done, I'm creating an image. Now to create that image, I need a runtime, and that runtime is coming from ASP.NET Core 2.2 because that's how the project was created. And now once it is built, I'm saying run it on port 80, which is the exposed port. And once it's ready, the entry point, the starting point is going to be the auth API DLL. That's the DLL that's generated from the .NET part of the system, and that's where my Docker is going to start the execution from. So once this file is ready is when you hit Docker build. It tries to find this file. It tries to find a file called Docker file in your solution or in the source folder that you're in, and then it would take everything from there and start running it. And if you look at this here, it's starting from here from Microsoft, the SDK, taking the 2.2 SDK, building it, and then using the runtime ASP.NET Core 2.2 to actually create the deployable image. So now that we have an image, the next one is actually deploying it. So for deploying it, it's I can do something like Docker service create, and then I'm going to say run it on a specific port. I can say take any port that I want, and then the port that I exposed when I built the project is port 80. So I want Docker to send all my traffic to port 80 on the running container. So this is your published port, and this is your port that the traffic goes to. And then I'm gonna name this a service. I'm gonna say test mail service. This is the deployed service, and then I'm just gonna do and I'm gonna define the name. This is going to be test mail service, and now I'm going to say which image is this based on, and that's going to be test mail API. So when I do this, it's going to go pull the image, which is test mail API, the one that we just created, and then use Docker to go ahead and deploy this service. Now this service, okay, so it says no.
I think when you built the image, you didn't tag it as latest.
No, it by default tags it latest. So I was missing the name thing. So I was thinking test mail service is the actual name for my image, but it was missing a parameter.
Oh, got it.
And it also used up the port, so I had to change the port. So there you go. So the service is now deployed, and it's running, and we can see that from again the Docker view here. It's gonna list, and there it is test mail API. That's the one I just created, test mail API on port 3233. And I can go in here, I can do localhost 3233. And this should pull up the documentation, which tells me the service. I can also hit it from Postman. That's another way to test it. But this is a quick Docker deployment of how it works. Now, I also want to show a few other Docker statements if you have time, Gaurav. Are we good on time?
You want to take some questions first, and then we can show some more details?
Yeah.
Do we have any questions? We have a lot of questions. I mean, I personally like how Docker is really easy to get. It feels easy to get into once you're in the middle of it, but is there a good way for people to get started with Docker? Or is there some useful guide or documentation or something you found helpful when you're learning to use Docker more effectively in larger environments?
Sure, yeah, I have a list of compiled references. I can give that to you for you to post with the comments. That's surely a good startup guide. And again, with Dockers, like you said, you can get really complicated. Like you can go into like too many complex things and stuff like that. But starting out simple, it's probably like a bunch of 5 statements, right? Like you said, it's you can start off really, really small and get it deployed. I've seen tutorials that would do that in like 20 minutes, less than 20 minutes, and that's all it takes to get started with Docker. But yes, it's a big, big ocean where you can then start going into a lot of other optimizations, customizations that you can do to get Docker up.
Cool. Anyone else have any questions?
Yeah, so where do you place your Docker file? Is it like on the web project that you have, or is it on the solution itself?
Right. So the Docker file technically can be anywhere where you're running your script from, but it would be best to put it with your application, because that way, whatever, like the commands that you see on the screen right now, it's much easier to compose these commands if you're in the same folder that your solution is in or your application is in, because you're basically copying files from the current folder into your output folder and all that. If not, you're then going to have to give defined paths for where your source is, where your destination is, where you want to copy the files from and move it to, and all of those things. But yes, the ideal place or the easiest place to put it at is with your source code in the directory that your project is in.
Anyone else have any questions or anything in more detail you'd like to see? You can also put your question on the chat. We can see it. If you don't want to speak up, that's cool. We've got a question. How would you compare implementing MongoDB servers versus SQL Server?
MongoDB is, I would say, and it's good, but SQL Server gives you the relational value that is hard to get with MongoDB. Can you do it? Yes, maybe if you try really hard. But with SQL, but with SQL Server, you get that inbuilt. And I think with a bigger solution and application, that's something that you would surely want, is relational database capabilities.
But both you can containerize, right? Because I've seen SQL Server containerises as well, or well, but generally you wouldn't do that. You'd have the first rule of containers is you do not put your database in a container.
Yes, unless it's like really small.
Unless it's Cassandra. I think there's one exception to the rule, where it's like you have to put it into a container. Otherwise, no.
How much of a size can you put on a particular Docker? Is there a limit? Or?
It depends on your host. Like if your virtual machine can take it, your Docker can take it. Okay. So, because I mean, Dockers are also running on a physical server. So whatever your physical server can take is what a Docker can take. It's using the same OS kernel, so there's literally no bounds to it. It's bound by what you have, actual specs on your server.
All right. Anyone else? Questions, comments, queries? All right. I think we can wrap up. Thank you very much, Mukesh, Murali, for for talking to us about microservices. It's really been great to see kind of learn the lessons about what you've learned about having a microservice conversion and that you've actually succeeded.
Thank you for having us. It was fun. Yeah.
So you said you have some source code available that you could put on GitHub. I saw you had the link to eShop containers, but this example that you put together, Murali, is this something that you can post a GitHub link to the meetup?
Yeah, I can Bitbucket or GitHub. I can give you the source code. Yeah, if you want to put it on your if we have one for the group, like a GitHub.
I think we have one, but if you have your own GitHub, you can just post it there and link it if that's good enough.
Yeah, I can do that.
Yeah, and we'll have the recording posted on Meetup, and we'll plan out for our next meeting sometime next month.
Okay.
Yeah, thank you all very much, and have a good evening.
Have a good evening, guys. Thank you.
Yeah, thank you.
Thank you.
Yeah, thanks.
Thank you.